So breaking down the basics here, this is a longer form content of safe operating limits. We're going to give you a good example of how you can build this from your PHA, from your other documentation. So the big thing that we talked about in the short portion is you want to build this from the PHA and then from subsequent meetings with your operations staff or your engineering personnel who are really going to know what these deviations do, especially from past experience. So the first thing is your PHA. When you're going through your PHA, you should have sectioned and noted out the plant and talked about different deviations for all those sections. So basically every operation, every mode that you have should have been considered in the PHA. Any of infrequent operations. And those deviations would have been talked about with a team that maybe consisted of an engineer, but someone that's familiar with production, someone that's familiar with the methodology that you use from deviation. So it'll tell you what's more important, what's a higher safety risk or a higher operational issue. And also you should have had somebody from operations staff. So this is a great document to be able to pull all this information from. Additionally, as we'll show you in the example, you can pull all the safeguards and those limits that you're really concerned about from this document as well. Sometimes we don't put as much detail in the documents for not wanting to change it every so often when we change an alarm set point. But those set points then should be in your operating procedures, or your staff should know what those set points are. This is key information for the safe operating limit table or document because those consequences of deviation are really the lifeblood of this document and how they can help your staff and your employees know what to do in an event or a release. It's really going to pay dividends for troubleshooting and pay dividends for response time when you do have something go wrong at the site. Here's a great example where I can show you where we take a PHA, something that we talked about in a PHA, and we use that documentation then to fill in our standard operating limits table and then talk about our consequence of deviation. So what you have on the screen right here, we talked about parameter pressure, chemical A is transferred at approximately 90 to 150 pounds to drums D123 and reactor 123. So in a higher pressure scenario, if we have a control loop failure, potential to raise the pressure in D123 and lift the PSV, releasing chemical A to the atmosphere and exposing personnel. We have our risks there associated with it. That's from the OSHA matrix there we just used as an example. Safeguards, high pressure interlock will close XV 445 on high pressure, and the system is lined up to the vent scrubber during normal operations. So this is just kind of a basic scenario that we may be covering in a PHA that we're going through with the team. It's going to seem super simple, super counterintuitive of why don't we do this all the time. SOL, COD tables are easier to access for our operations personnel. Here's an example of one. Just vessel parameter, upper limit, lower limit of the system, consequence of deviation, and how do we avoid that deviation. Okay, so vessel parameter, we pulled in here D123. The pressure parameter that we were talking about, what's the upper limit? In this case, 150, okay? And lower limit, we'll say the tank's rated for full vacuum. So that lets our operations staff know these are the upper limits. Now, those upper limits are going to be based on what we normally operate at. So when we say upper limits, those are the boundaries at which can be operated. All right, so you have a couple layers there. You have your normal operation. You have a layer that then reaches from normal operation where you would like to run high to your upper limit, so that you're in the high range. And then you have your high range when you go above the upper limit. Same thing on the low end side of it, okay? So what we have here is we're listing the upper and lower limit. These are what we call our high and our low points. And then consequence of deviation. From this, if we raise the pressure, we pulled it straight from our PHA. Potential release chemical A from a PSV. All right? Steps required to correct or avoid. We looked at our operating procedures and our PHA, and we said on high pressure when the vessel's lined up to R123, 123 is probably having pressure control problems. Okay, so that's something that we know. We did say, though, hey, we have an interlock also. Take a look at the system and make sure this is working correctly. It's going to close the XV 445 on high pressure. Also, you want to verify if the PCV are properly lined up. PCVs are properly lined up. That's on our nitrogen line for the system. We pulled that from operations. We didn't talk about that in the PHA. But we did talk about the systems normally lined up to the vent scrubber. So one action there here in our table is verify that the vent scrubber is properly lined up in the system. So this is just an example of how you can take a tool. In a PHA, you have all the specialists in place. You have all the people who know about engineering, about the technology, about the production, about the operations, about maintenance. Let's take all that good information and let's put it in this operating table and consequences of deviation document that our operations staff can then use, can access, and on a daily basis can help our plant not only run more efficiently, but run safer. Hope you like the content. As always, you can check us out on YouTube, LinkedIn, Facebook, or at our website.